Okay, hello everybody. For those of you who are here already, pull out your laptops. We want to do some setting up in the shell. I prepared a little bit of information on what you need to have installed to follow along on what I'm going to show you. So if you want to participate, make sure you have WireGuard installed on Linux, WG Quick installed. And if you need access to HOPR if you don't have one running yourself yet, we have some handouts up here on the table, which have the required information for this workshop for a temporary node, which you can freely use in order to get yourself set up in this workshop. We're going to wait like 2-3 minutes maybe. It's lunchtime. People are finishing up, and then in 3 minutes, I'm going to start. Okay, let's get started. No worries. The things you have to prepare, if you haven't done that yet, you still have plenty of time left in the workshop to do this. And I'm going to mention it later one more time anyway. If you need a handout, up front are some on the small table. So just pick one. Okay. So today I want to show you and give you a first-hand experience on how to set up the GnosisVPN proof of concept client. My name is Tino. I work at HOPR, and I'm involved in all the technical and engineering stuff as CTO. And GnosisVPN is our latest endeavor to make the work we do at HOPR, which is very low level and concerns privacy in the internet, make it usable and bring it onto a level where a normal internet user who is not technically savvy can actually leverage it to improve their own way of using the internet. So again, this is currently a proof of concept. So we are right in the middle of product development. And right now, you still need to be quite tech savvy in order to install the client and use the VPN connections. That's why we have this workshop. All of you are quite tech savvy. And I want to give you the instructions on how to get onboarded. And hopefully you find this interesting enough that you follow us along over the next month and years in terms of bringing this product to market. Just really shortly, this is our agenda. So first, I'm going to give you a little bit of an overview of what GnosisVPN as a product is actually meant to be and why we want to build it. Then a really short introduction to what HOPR is, because HOPR is a fundamental component in GnosisVPN. And then we dive into the practical aspect of this workshop. So this is actually the part where you should pull out your laptops and try to follow along on what I'm doing. At the end, you should have the same setup running, like I'm going to demo, and should have an active VPN connection working. And then I'll give you a little bit of an outlook on what's next in product development for NosisVPN and what you as a user can expect. And Q&A. I think there's some automatic Q&A where you can post questions up here, but also feel free, like in the previous sessions, to just raise questions right away. You have to maybe shout out, especially for the ones in the back, because I don't see you very well if you just raise your hand. So just give me a shout out. Okay, why VPN? So VPN is something which normally, okay, you only see half of it, which you might have heard before. Quick raise of hands. Who here has actually used a VPN before? Okay, pretty much everybody. Who here is using multiple VPNs? Okay, that's still almost everybody. And who here has built their own VPN? Self-hosted or like custom built, only you are using it or your family? Okay, still quite a few people, a handful. So VPNs are everywhere. Like we usually use VPNs synonymous for giving people more private access to the internet. It's a $50 billion industry, and yet I think it's fundamentally flawed in the way it's setting up users to fail in terms of private internet access. One of the reasons is, as you can somehow see in this slide, so there's usually, the slide isn't complete, there's a line going from the top left user device down through the arrows all the way here and then back on top, right? So there's one line connecting the user device and the web service through the VPN exit node. What does it mean? When you use your VPN, you normally have a centralized VPN provider, a company which runs servers around the world, which you use to connect through. Now, normally when you use the internet, you're actually not using a single company's servers to push all of your traffic through, right? You're making it, comparatively speaking, difficult to an adversary to see what you're doing. Once you're using a VPN with a single VPN provider, what you're essentially doing is you're pushing all of your traffic through a single company's servers, making it really easy. You're making that job really easy to actually see the kind of internet traffic you're pushing. Right? That company has access to the patterns of your internet usage. When are you using the internet? What are the kind of uses you have of the internet? Like, do you do more social networking? Are you watching Netflix? That kind of stuff. So why they might not be able to inspect the content which you're sending around, they see your behavior. And this is a company to whom you might not even have a proper trust relationship, just some VPN provider. You know, what could go wrong? And this is the fundamental problem where this big industry, which is actually relevant for privacy, pulls people into this false sense of privacy. Ultimately, what you're doing is you're trading that little bit of extra access. Let's say if you want to stream Netflix from a different country, you're trading that ability with the access to all of your behavioral data when you're using the internet. And because this is flawed, we want to build something which improves the state of art using the HOPR network. But there's also different other approaches in the market right now which try to improve that state of art. So it's a really exciting time for VPN providers. So people are trying to build a better internet. And hopefully at the end, if we look ahead a couple of years, for the general internet user. So again, why are we building NosisVPN? Trusting VPN provider is not good. It's literally trusting a company which is oftentimes traded on the open market, and therefore it's exposed to all the general problems in terms of data harvesting, which any company is. And we need an open internet, which requires private communication, and that communication doesn't become more private by using a VPN provider. So we need something which enhances privacy through different means in order to make the internet access more private for all users. Now, NosisVPN tries to tackle that in a couple of ways. One is we want to remove that single trust anchor. So there shouldn't be a single company you have to trust. Ultimately, it should be a decentralized ecosystem, a decentralized network, which you use, where trust doesn't play a role anymore. You, as a single user, shouldn't have to put all of your trust into a single entity. And then it should be censorship resistant, which is also really important for a VPN. As most of you understand, you don't want to be shut out from using the service, the web service you might have access to in your country, from using that same web service from a different country while you're traveling, or vice versa. The VPN itself runs on top of the HOPR network, which I come to later. And it's currently in PoC stage, so it's really technical still when it comes to how you use it. So don't be surprised, we drop into the terminal or the shell later in our practical part. But this is exactly what we're building upon now. We are trying to make it more usable. It has to become familiar for users. So a VPN is something users already know. So whatever improvement we build has to be on par with that usability. So we cannot be worse, and this requires a lot of product development. All of the work we're doing on the product side on GnosisVPN is actually funded by the Gnosis DAO. You can check it out yourself. There have been 2 public GIPs, 98 and 122, in the forum available. Here's the link or the QR code if you want to get some more details on what our plans are and the kind of product development states. Okay, coming back to our original VPN architecture, and I already mentioned why this is not ideal for open internet, private open internet access. The way we are going to improve this is by getting rid of this single VPN provider down here, right? We have to erase single entities and somehow make it use a decentralized network and trustless technology. So this is where the HOPR network comes into play. It becomes the fundamental transport layer of all VPN connections, all VPN data. And it's sitting in between the clients, which in our case here is, let's say, a web browser, and the services on the other side, which are, let's say, websites which you try to access in your day-to-day internet browsing. So what happens on the left-hand side, excuse me, on the client side, you actually have something like a VPN client running. And now eventually this will be a UI client which you install through normal means, the App Store, for instance, on macOS, and which has a UI where you can click start and your VPN connection gets started. Then that data is routed through what we call an entry node to the HOPR network. Because the HOPR network is so fundamentally different from the normal internet protocols like TCP or UDP, there needs to be a node in between your client and the server which connects these 2 worlds, and this is the entry node. Then all of the data passes through the HOPR network in a fashion which makes all of that way more private through anonymity, which I got to later. And then on the end, again, there needs to be a node, the so-called exit node, which translates whatever the HOPR network is speaking to the outside world, to HTTP requests or normal TCP and UDP connections. And then talks to the outside world, the internet, and routes the responses back to the user device. So as you can already see, we erased single point of trust because we're talking here about a decentralized network sitting in between, but also complexity is now going way up. If you look back at our original architecture, this is really simple. Like we had a couple of people in the audience who have run their own VPN, and it's comparatively, if you're technically minded, comparatively easy to set up because the architecture only relies on that one single component. But now we're talking about a decentralized network sitting in between of all of this. So making that usable in the same fashion like any current VPN is usable for end users is quite difficult. And that's a challenge, and that's the reason why anybody who's attempting to do that, kind of raising the bar on privacy, not just GnosisVPN, but other products, is not doing that overnight. This is not a development which you can easily do. You rely on very difficult technology underneath, and making that usable is quite a challenge. So coming into that lower level, what is HOPR actually? HOPR is a mixnet which uses the method of mixing packets to create higher levels of privacy through anonymity. What happens in a mixnet is actually that you don't have direct connections anymore between two nodes. So let's say client and server. Instead, all of these connections are fundamentally broken up into many packets, each packet to the outside world looking the same because they're all the same size. And then they are sent through different paths through the decentralized network. Eventually, all of these packets will end up at the same point, the destination, the server, who has to put that back together and then perform whatever service you wanted and originally be performed. And the same on the response path, then the destination has to split up whatever response is being given into many packets, and these are then sent through different paths through the decentralized network and on the entry side being put together. An important aspect of the HOPR network is that it's incentivized. Incentivization is really important to make it sustainable in the long run, because otherwise you cannot have a network with very, very many nodes where, for instance, each one of us in this room are running a node, and you have to be incentivized to do so. You don't want to just run a node for the good of the community, although I think many of us would do so. Eventually, it has to be self-sustainable, and that's why we incentivize the hosting of a node and the serving of traffic intrinsically in the protocol. Coming back to mixing, because it's a really important aspect, and I just want to give you a couple of more details on how that works. I mentioned already that every packet which flows through the network is the same size. This is important because it makes it indistinguishable just based on the size for an outside observer. What we try to do in a mixnet, and this is not only the case for the HOPR network, but other mixnets, is try to make it as hard as possible for outside observers, adversaries, to figure out your communication patterns. So packets come into a single node, they are being mixed with other packets, which are either generated locally as so-called cover traffic, or which come from other nodes to you. Then they get some added ingredients, which is latency. We actually add time in between the packet coming in and the packet going out in order to make it even more harder for adversaries to figure out that packet A came in and went out a certain direction. And then these packets go out again. So what you see from an outside perspective is a certain packet order coming in and different packet orders coming out with packets you cannot even identify anymore as the ones which came in. This is the fundamental concept of mixing in a mixnet. And then there's the sustainability aspect. I mentioned that already. It's really important for a large-scale decentralized network to be sustainable, for node runners to have an incentive to keep the nodes up and running. And therefore, what happens is for every packet which is relayed through the HOPR network, there's actually an incentive, like a token attached to it, which or a promise attached to it, which once you forwarded the packet, gives you access to funds which the original party has paid for already. So think about it like when I want to send out a packet through 3 hops through the network to the final destination, I actually have to pay upfront verifiably 3 pieces of a token, let's say. Each of those hops in between gets 1 piece of that if it performs its service properly, and therefore each of those hops is incentivized to do their work and keep the node running. This, in the long run, will enable the network not only to grow, but also not to stagnate too much, because nodes keep up, they stay up, and therefore this is very good for the health of the network and availability and throughput in general. Okay, so much for the theory. This was really a fast track, very high level. If you have any questions on any of the details, feel free to come to me afterwards, or tomorrow I'm going to be around, and I'm happy going to give you more details on HOPR, on GnosisVPN high-level architecture. But for this workshop now, let's imagine you're in a scenario where you're in a cafe, or even better, you're at a conference, and that conference wants to provide you anonymous internet access through giving you access to the Gnosis VPN. Now, in order to run the VPN, you still need access to HOPR, which we'll get to right away. So let's try to get that VPN client set up for everybody here. The technical steps we're going to cover are outlined on this diagram. So first, we're going to access a HOPR node, or get the access credentials. If you have your own node already, you are safe. If you don't have a node, we have handouts here, with the required information, which you can use now in the following steps. And then, if you're excited about it and find this useful, you can set up your own HOPR node later, which I'm going to help you with happily also. So that is step number one, right? We need to get that entry node here set up and accessible. Step number two is installing the VPN client and configuring it properly on your machine. So that's your laptop. Step number three is configuring a web browser. One limitation of the PoC right now, since it's a PoC, is you have to configure your web browser to use the VPN connection. So it's not being exposed for all of your traffic yet, right? But only for the traffic you choose to run it over. Step number four is starting the connection. So starting connection means entry node is able to connect to exit node, and we are able to create a secure connection over that line. And then we're going to test the connection and access some websites. Okay, so there's a couple of commands which are hard to type. So that's why follow this link down below, either through QR code, or the link is really short. It should take you to a page which has all of this in a copy-pastable form, so you don't have to type out the GitHub links and bash install commands yourself. I'm just going to wait a couple of seconds for everybody here to use that QR code. Is it working? Can I get a thumbs up from somebody? Okay, cool. Damn. Okay, wrong QR code. Sorry. Then just type out the link here. Okay. No. Yes. I'll get to that. Yeah. Okay, so everybody was able to open this website, t1p.de/k9fy5. Okay, cool. Then I'm going to drop into my shell as well and basically perform the same steps like you are going to perform. So first, we're going to download and install a script. I mentioned it's a PoC, so we don't have a UI installer yet, and the GnosisVPN PoC is not available in the app stores yet. So you still have to download and set up some stuff yourself, downloading binaries, setting up a configuration file. To make this easier, we created this bash script, which will basically guide you through the steps and explain to you what's happening. So at the end, you should have an understanding of what just happened and which files were created locally in your test directory. Okay. So yeah, I have two windows. Can you read this? Wait, let's make it bigger. Yeah, okay. So I'm just in some temporary directory which I created before our workshop, and I'm going to download the install script first. Obviously, I'm connected to the internet, so that's mandatory. Let's check. Okay, install script is here. And should always check out what a script does, which you download, so you can take a look at the content and make sure it's not doing anything malicious. So then we are going to execute the script, and we want it to install a specific version of the POC binaries. This is such that we don't get an untested version, which I didn't test for this workshop yet. It doesn't mean that the latest version is broken, but there's lots of progress going on all the time. So my colleagues might have pushed some change while I'm talking, and I don't want this to interfere with what we show here. So we are using version 0.10.9. So be sure to set the version tag correctly. Right, so bash install sh version tag and then 0.10.9. And there we go. So I mentioned the script is very interactive. It tries to give you as much information as possible on what is happening and which steps are being performed. So here it tells us it will download the client and control applications. It will prompt us for the required API access information. So this is on your handouts. It will also prompt us for a port, the internal connection port, which is also on your handouts. And then it will generate the required files for us. Now I should mention, these steps are different for users on macOS than for users on Linux. So if you have a Linux machine, you have an even nicer experience than what I'm going to show you because it's a more automatic setup. You can skip the entire WireGuard part and it won't even ask you for it, while I'm going to show you some WireGuard setup here too because macOS is not automated that way yet. But eventually you will have the same VPN connection setup. Okay, I'm going to continue. It's asking me for a target directory where I want to install the binaries. I just keep the default. It can be anywhere though. So just enter. It also identified, and that's worth noting, the architecture I'm running. So here I'm running Darwin 1. So it's going to download the right binary. Depending on whether you're on Linux or maybe have a normal Intel CPU, it will download a different binary for you. Then it needs the access information for the API to the HOPR node. So again, the VPN needs to talk to a HOPR node. And since most of you might not have a HOPR node running, we have created these temporary nodes for which we've also made the handout. So each handout actually has access information to a different node so that you don't interfere with each other and have a good experience. Now, this one, the admin URL, you don't have yet, right? So what we're going to do instead is you can just leave this empty. So hit enter, and then it's going to ask you for the HOPR-D API endpoint. And this is actually value number 1 on these handouts, endpoint equals, and then HTTP something. So you just enter this here. I'm going to do the same. I picked one of those handouts. So no special treatment for me. Okay. So protocols HTTP, we have some IP, and we have the API port, which is 3001. Now coming back to your question, why is it actually HTTP? Normally you shouldn't expose that through HTTP because you know, you're sending over potentially sensitive information. over the API, so it should be HTTPS. This is just for the sake of getting those nodes up and running really fast. So any normal deployment of a Hopper node should use HTTPS and have that API port exposed over HTTPS only. Then I'm being asked for the token, which is the second entry on our handout, and it's called PBV2 underscore GnosisVPN underscore 2025. So let me enter this. All capital letters. Okay, hitting enter. And now it's asking me for the so-called session port. I will get into more detail after we got the full connection going on what the session port actually is and why it's needed. Just briefly, this is the port which eventually WireGuard will connect to, right? So we have to give the VPN client a port which it's going to ask the HOPR client to use. On your handout, it says internal connection port. This is basically the session port. So you can use the 9100 or 9095, depending on what is on your handout. So I have 9100, hitting enter. And what happened now, it already tried to access the HOPR node, and that worked, right? So this is good because it showed that the API information at least is correct. So the HOPR node is there and running. And it has not downloaded the binary. Provided version tag is not valid. Let me try again. Maybe it's without a V. Thank you. Thank you. So what do? Yeah. Okay, what do? Has anybody been able to use and download the binary actually? You did. Okay. Anybody else? Raise of hands. If it worked, you can quickly check like this, right? And it should show you the new directory, GnosisVPN, and the binaries in there. It should be 2 binaries. Yeah, let me try again. I mean, no harm. You need a VPN to set up a VPN. What irony. Okay. So I don't have to type it out all the time again. I go mobile, exactly. Hopefully that is working. It's not. I might have been too fast. Okay. One more time. Bear with me. And maybe while I did that 3 times, you already managed to download everything. Okay. Moment of truth. Yes. Okay. So finally, I was able to download the binaries. Hopefully, somebody here, in addition to us two, also managed. I connected to my mobile phone. Yeah. Sorry. So on any normal Wi-Fi, it should be working. Not our shared Wi-Fi from the conference. Not yet. So this is the last step for macOS. Linux users are done by now. macOS requires you to enter a WireGuard public key. So that's why I mentioned earlier that you have to have WireGuard installed on macOS already, which I did. So what I'm going to do is I'm going to open, can you see this? Yeah. I'm going to open WireGuard and create an empty new tunnel configuration. So I'm going to call this demo protocol Berg 2 and just save it. This configuration is unusable like this, but it gives us a public key which we can use in our configuration for the VPN. So we copy the public key from that empty WireGuard configuration and give it to the install script. And now it's downloading the binaries, which is working. Now we just have to wait. It's actually downloading two binaries, which I'm going to explain later. And also, again, very specific to macOS, binaries which you just download like that are normally quarantined, so you cannot use them. And that's why the install script disables the quarantine for you. You just have to provide your password, local user password, and that's it. Okay. Yeah. Okay, so now I have everything set up. If I look into my directory, I see 3 new files, 2 binaries and 1 configuration file. Also, the install script told me a little bit about what just happened. As you can see here, it actually gives you the commands which you need in order to establish your VPN connection. So these are roughly the same commands which I'm now going to showcase. So you can just copy paste from your output on your own machine in order to get things going. So I will go into my directory. I have binaries here. So next step is to actually start the so-called VPN service. So that service is the one which manages your local connection. It has to have elevated privileges, so that's why I need to use sudo in this case. And you have to point it to your configuration file. And here you have to make sure it's a full path or a relative path with the /, right? So not just a file name, but a proper path in order for the binary to find that file. So I just execute that. And as we can see in the output, it started in manual WireGuard mode, which is the default on macOS. And it basically has a clean start. I haven't started it before here. There's no previous socket set up or anything. So this is a clean slate. Now I can go down into my second window. And I'm going to use the sister binary, the control binary, which is used to instruct your service now on what to do. As of now, the service is not doing anything. It's configured properly, but it's not actively opening the connection. That's what you have to do yourself. So if I ask it about its status, it's going to show me that status is disconnected. But there's 2 available destinations, like in any VPN, which I can choose from. So we have 1 destination in London, and we have 1 destination in Iowa in the US. For this demo, I'm just going to try to connect to the London destination. So I'm copying the so-called peer ID, which is the identifier in the network. And then I'm going to use the same binary to connect to that peer ID. So it's GnosisVPN control, command connect, and then the peer ID. So doing that, we see stuff is happening in the service output. So the service is now actually trying to connect to that exit node, and it's successfully connected to the exit node and shows us now how we need to configure WireGuard. If you would be running this on Linux, you would be done by now, because Linux does all of that automatically, or our Linux version. On macOS, I now have to take this output and I copy it. Hold on. copy the output, and then I go into my WireGuard configuration, which I created a couple of steps before. I edit, and then I paste it down here. Now it's really important that you don't delete your private key up here. This is something which you should never do. Make sure you paste it, everything is pasted below your private key. And so a normal configuration should ultimately look like this. You have your interface with a private key and an address, and then you have a peer definition in WireGuard. Yes. The configuration, you should get an output here in your service, the service you started. Yeah? Okay. Once you execute connect down here, the service will try to connect. And if it made a successful connection, it will give you the WireGuard information. How to start the service? Sure. Okay. So backtracking here, I have to do this twice then. So I'm going to shut it down. So like this. So we sudo execute the gnosis_VPN binary -c to give it the configuration file, and then needs to be a proper path. So I'm using a relative path, which is // and then my config file. You can also use a full path if you need to. And this, executing that will then launch the service. Okay. You don't? Interesting. Okay. Just after the workshop, come to me and we'll figure it out. Okay, so I'm going to connect again. I get my WireGuard information, which is always new every time I connect again. So I have to copy it again into my, my WireGuard, pasting it in here. Okay. So we still see that our service is asking me to create that WireGuard configuration and make the WireGuard connection. I haven't activated yet. Now I can activate the connection, and then I'm going to see something happening in the service itself. So connection is running, and now the service recognizes there's an active WireGuard connection, and it can actually ping the other side. It can see that the VPN connection is working, and it's going to monitor that to make sure the VPN connection keeps working, right? So this is a good indicator of everything went through so far. So now we need to make it usable. Remember, I said we have to configure our web browser. My web browser of choice for this demo is going to be Firefox. So opening Firefox. And in Firefox, we have to configure a so-called HTTP proxy. In order to do that, you have to go into the settings of Firefox. So you go to the burger menu on the right, all the way down to settings. And then in the search, you can just look for network. You go into network settings. And as you can see, I pre-configured it. Normally, it's set to no proxy. What we need to do is we need to manually choose the manual option, manual proxy configuration. And we set the HTTP proxy endpoint to the given IP. So that's 10.128.0.1. This IP is basically on the other side of your WireGuard connection. Your port is 3128. And really important, we want to use it for HTTPS as well. Because normally the internet is mostly HTTPS. You couldn't use it in HTTP mode only. So that's why you should use a proxy for both. So make sure you tick the box too. you can go to OK. The IP is also in that on that website, which I mentioned earlier, so you can copy it. And now we can try to access the internet through the VPN. Trying to load the protocol Berg website here. It's loading and it worked. To make sure it's really working, we go to the old one. And that one is also loading. Great. Now let's see whether I'm really connected to a different network. So I'm going to ask, what's my IP? And this is showing me London. So I chose the London endpoint, if you remember. And I'm being terminated in London here. So this is great because it shows the internet is seeing access through London for my laptop here. So just to give you the comparison, if I wouldn't have the VPN running in a different browser, let's say, I'm getting quite far away, Aachen, which is on the other side of Germany due to me using my mobile access. So this is how internet access looks like if I don't use the GnosisVPN, and if I use GnosisVPN, it's going through London successfully. Anybody here managed to get a working connection going? Okay, I will happily assist you afterwards. So I just want to move on with a couple of more details, and then at the end, we can work through all of your problems in setting this up. Okay. So I showed you macOS. I mentioned Linux is working even better, bless you. Windows is a little bit more complex. We don't have native support yet for Windows. It's on our product development plan, but you can make it work through what is called WSL. So basically a Linux subsystem on Windows. If you just follow this link, it has some instructions which you can use to set it up and get basically the same experience like I just showed you. Yeah, I basically went through these steps. So on macOS, the WireGuard setup was a little bit more involved. We started the service, we connected and copied the configuration. We configured our Firefox, and eventually we had a working connection. Yes. Yes. Yeah. For now, that is a limitation for the POC, and it's slowly going to be lessened as a limitation as we move forward with the product. Eventually, obviously, a final product, a final VPN should tunnel all of your traffic from that laptop through the connection. All right, so what did we actually just do? Taking a step back and looking again on how the VPN connection works. What we did is we configured our entry node locally. We configured our GnosisVPN client on our laptops, and we were able to get a VPN connection going from the user device all the way to an exit node and access through the web browser the internet through that exit node. Now, this looked really simple, comparatively speaking, but under the hood, all of these requests to the internet actually went through the HOPR network. They were all chopped up, as I mentioned, into packets, sent over different connections through the final exit node. So all of the stuff, the heavy lifting, which you need in order to get that added privacy and anonymity is already obfuscated here for you. It's transparently available to you through GnosisVPN. If you look a little deeper, and this, you obviously don't have to understand all of what has been shown on this slide. It's probably barely readable for you. But what I wanted to highlight is, as we saw when we started the connection, we typed GnosisVPN control connect, and then we connected to a particular peer. That connection setup is already being performed over the HOPR network, meaning even the process of creating your NosVPN connection is already hidden away from any adversaries who want to see what you are doing, right? It would be a very bad signal if that connection setup is visible to the outside, so people understand, okay, hold on, that internet user is trying to use NosVPN now, and then everything is protected, because that's a bad indicator or that's an identification piece of data. So we also want to hide exactly that bring up. So this is a protocol, the connection bring up protocol, which is running entirely over the HOPR network already. So it's hidden away just as the VPN connection itself from prying eyes and adversaries who want to look at what you are doing. Now, taking one step further, once we have a VPN connection going, we saw that a VPN connection involves the HOPR network. It involves, for some reason, WireGuard. We are connecting to web servers over the internet, and we are using our web browser. So a lot of components. And all of that communication is somehow layered. If you just use your local web browser to access the internet, you have one connection layer, and that's direct TCP connections, HTTP, between those two. So if you look at, on this graph, on the left-hand side, the web server, and on the right-hand side would be your web browser, you have one HTTP connection, which is comparatively simple. If you now add WireGuard into the mix, what happens? WireGuard creates a UDP-based communication channel between a client and a server. So WireGuard client and server. On the left-hand side is the WireGuard client. On the right-hand side, the server. No, the other way around. Left-hand side is server. Right-hand side is the client. So what happens is WireGuard tunnels transparently TCP packets over UDP packets. So you're encapsulating somehow TCP packets into UDP packets, and on the other side, you have to decapsulate UDP packets into TCP packets, which, as you might imagine, adds quite some complexity. To take this even further, HOPR comes into the mix. So now we have the HOPR-D exit nodes and entry nodes, which WireGuard has to communicate with. And HOPR is not talking specifically UDP or TCP between HOPR nodes. HOPR is talking the HOPR protocol. So different packet format, different contracts between the various nodes, running through many hops, and so on. So all the complexity of the HOPR protocol. So now we have TCP being encapsulated into UDP, being encapsulated into HOPR packets, which, if we go all the way back toward the beginning where we just had HTTP, is quite a huge increase in complexity. It shows not only in the throughput of VPNs. If you add more tunneling, you get less throughput. So VPN is always going to be less performant, like your plain connection. But also, this seems very, very daring when you are an application developer trying to use, let's say, HOPR, because you eventually have to encapsulate 3 layers and think about that and somehow make that usable. So that's why, and I only mentioned it briefly here, so if you're interested in that, I can tell you more about it after the workshop. We have something called the HOPR session. What we actually do in HOPR is we don't have a specific protocol exposed to application developers. Instead, we expose TCP and UDP ports. So TCP ports and UDP sockets. So as an application developer, what you can do is, if you want to use HOPR as your transport layer, you can transparently open TCP connections to it. And eventually, those will be then tunneled through the HOPR network to the exit nodes. And there, whatever target you have for your TCP connection will be connected to also via TCP. So you get transparent TCP and UDP tunneling for applications. And that's exactly how we made the VPN work. Because WireGuard does not speak HOPR. WireGuard does not know anything about HOPR. It's a very basic VPN component which only speaks UDP. So instead of trying to teach WireGuard HOPR, we taught HOPR how to speak and expose the UDP socket. And therefore, WireGuard can transparently talk to HOPR over UDP and just don't, it doesn't matter to WireGuard that it's even talking over Hopper. This is, from an application developer's perspective, really cool because now you can go in and have a lot of ideas on how to use the Hopper network, and you don't have to worry about new APIs. If you already know TCP and UDP, and by extension, TCP is HTTP, you can use it almost immediately and have a very seamless experience. Sorry, that was a question. I was not ignoring you. Okay. Yes. For the NosVPN specifically? Yeah. Very good question. Can I just push it for 5 minutes? Yeah? Cool, thanks. Any more questions? So this is just to give you a hint of the complexity which NosVPN tries to hide away, right? But also through the work on NosVPN, we actually were able to create a really nice application level interface. TCP and UDP are standards in the internet. So any application developer can use standards to interact over the Hopper network. So coming to the roadmap, and this is kind of also where your question went to. Right now we are in the POC stage, which is done, I would say. So we have CLI-based binaries. They require technical experience to use, but it's kind of okay. And we can have a working web experience, web browsing experience. You can use GnosisVPN on a daily basis, browse the web, which is quite cool. So that means end to end, we kind of made the concept work. We kind of tick the boxes. Okay, this can work. Now we have to put it on a different level when it comes to usability. So what we need to do to make it a minimum viable product, and that's the work we are in right now, is we have to improve or even further improve anonymity through, for instance, return path, but also other measures. So that communication over NosVPN becomes even more private. We have to remove the dependency, and this is a big one, for a separate Hopper node. Like I had to give you access to temporary Hopper nodes so you are able to follow me along on this demo and create VPN connections, right? After we are done with this workshop, I hope that every one of you starts up their own Hopper node and uses it. Eventually, however, this is not a good end user story. We cannot ask half of the world to run Hopper nodes. So what we instead need to do is we have a plan to integrate Hopper nodes right into the application. We call this the Edge node protocol. So what that means is you have a library, which is, let's say, the Hopper node library or the Edge node, and you put this into the application. In NosVPN case, that would be the GnosisVPN client. And it's bundled as one, and you never, as a user, are exposed to the Hopper network itself. You never know that you're actually using the Hopper network. You should not know. The only thing you care about is installing VPN client and having a secure connection. And this will then allow us to broaden the user base, not only making this usable by technical people, but also by non-technical people. And then we need unrestricted web browsing, streaming, what have you, file downloads. All the stuff you do on a daily basis should be possible. The final version number 1, which I would call the version which is on par with existing VPN clients, then has to support Windows, obviously, natively. We have to support mobile platforms like iOS and Android because you want to, especially on your mobile phones, be secure. We have to have incentives for exit node runners. And this is exactly covering your question, how do you become an exit node runner and why would you become an exit node runner? I hinted at it earlier. The idea of NosVPN is to become an ecosystem for VPN exit node providers. We don't want a single provider to be the target for all VPN connections. Instead, ideally, every one of us has an exit node running, and it's transparent for me whom of you I'm using. I'm just sure I'm using one of you, one of the ecosystem, and somehow you have incentive to give me that service. So the incentivization part is really big. This is R&D, so I cannot tell you the solution yet, but we have to figure that out. And then ultimately, it should be a permissionless process. So you shouldn't have to ask anybody that you want to be an exit node runner, but instead, as with lots of things in Web3, you should have a permissionless process to register your exit node, and then through a reputation mechanism, stay an exit node if you behave well. If you don't have good service or are not available, then you're pulled out of the exit node provider pool or something. And eventually higher throughput. That's really important because a bad usage experience because of low throughput will drive away any user. So we have to have good throughput, good latency. And therefore, it must be good enough for everybody to use on a daily basis. So next steps is obviously, if you have a working connection, browse the internet with your connection. If you don't have a HOPR node yet, maybe talk to me and get to become a HOPR node runner, and then you can have your own connections going all the time. I would appreciate, obviously, if you give us feedback on what you would like to see a product like GnosisVPN become, what's important to you, and maybe if you want to stay in touch, you can follow along on gnosisvpn.com on our progress. Every time we have releases, obviously, we put new information on gnosisvpn.com and also put that on the various social channels. So feel free to subscribe and give us feedback all the time. I think this product only becomes as good as it can be if we get as much early feedback as possible. And you are in that cohort, so thank you very much. Sorry, I was ignoring you all the time. Yeah. What exactly did you do? Yeah, okay. No, that's actually right now it's by intention, albeit unusable. So this is by intention because basically what the HOPR node sees is you were client A, so there's an existing UDP connection going, and then all of a sudden you switch and you send packets from somewhere else. This could be an attack. Exactly. So right now, this handshaking is not being done automatically. This automatic reset up. So it's by design right now, but it's not usable. So it has to be improved later on. Yeah. This is also a really good point, and thank you for running a Tor exit node before. Obviously, that's a huge inspiration. I think we can learn a lot from the Tor community and ecosystem that way, and that the community has to provide not only legal support in the way of how do you handle this, depending on your jurisdiction, but we also want to provide tooling on how to mitigate let's say, mitigate problems in access which in your jurisdiction you cannot cope with, right? Depending on which country you live, there might be different legal limitations on what you can actually serve. And in order to enforce that, you need tooling. And over the time, we want to develop that tooling so you can basically have an exit node or exit provider tool set where you can pick and choose the kind of block listing, traffic shaping setup you need in order to stay safe as a provider, yet still provide as much access as you can. Yeah, yeah, yeah. Exactly, yeah. So, I mean, if you want, we can chat later. I think this is for the next 1.5 years in terms of product development, a really important topic which we have to figure out, and we are actively trying to find people to talk to who are interested in that. So, obviously, happy to chat later. Yes. Exactly. That was the same question he had. So right now it's managed by Gnosis because we are still in POC stage and we don't have that permissionless automatic registration set up. Eventually, what we strive to do is build an ecosystem which is permissionless. So you can come up and register your exit node. Be like, I want to provide access, just like I use a network as a client. And but we need two things for that, or even more. But the two important things is it needs to be incentivized for you to do this, and it has to be permissionless. There cannot be a single gateway, a single entity saying, "Hold on, where do you live? What do you do? You know, who are you?" Before you get access. So we have to solve these things. So that's why it's on the R&D pipeline, but it's part of the product development plan too. So. Yeah.